Hi there, the Math Dog here. In this video I'm going to look at coterminal angles. I'll call this Introduction to Coterminal Angles Part 1. There may be a Part 2 video later. So you should have some familiarity with the unit circle before watching this video. So the parts of an angle that we need for this video to be familiar with are the initial side and then what we call the terminal side where the angle ends. So if I rotate this way, this would be a positive angle when I go counterclockwise, but I could also spin this way to get to the terminal side, and that would be a negative angle measure going clockwise. So there we have the standard unit circle, which is a circle radius 1. We assume here that one revolution is 360 degrees, which is 2 pi radians, and when we generally talk about coterminal angles, that is what we're referring to. One revolution will be equal to 2 pi radians, okay, and that's how we're going to go about this here. So again, unit circle has radius 1, so I'm looking at an angle of pi over 4, which in the special right triangle here is a 1, 1 square root of 2 triangle. That angle's pi over 4. This angle's also pi over 4. So I'm going to use radians here, but pi over 4 is 45 degrees. So in this video I'm going to use radians. So unit circle again, here at this position here, the coordinate is 1, 0. This would be 0, 1, negative 1, 0, 0, negative 1. So notice the unit circle, on the special right triangle here, this, the 45, 45, 90 triangle, again pi over 4 is 45 degrees. The ratio is 1, 1 square root of 2. Well, notice on unit circle it's going to be, this coordinate of this point is going to be 1 over square root of 2, 1 over square root of 2, because all I did was I took a similar triangle to this one and I divided everything by square root of 2. Well, square root of 2 divided by square root of 2 is 1. 1 divided by square root of 2 is 1 over square root of 2, and then 1 divided by square root of 2 is 1 over square root of 2. So also, just to remind you, this is not simplest radical form, although actually I like it better this way, personally. Usually you're going to see that written as square root of 2 over 2. So 1 over square root of 2 is equivalent to square root of 2 over 2. So now we're going to talk about coterminal angles. So coterminal angles have the same terminal side. So again, if I'm at pi over 4 here, the angle pi over 4, which has coordinates 1 over square root of 2, 1 over square root of 2, if I rotate 2 pi in a positive direction or counterclockwise direction, I end up where I was before. So that angle would be a coterminal angle, 2 pi over 4. I could also rotate negative 2 pi and I end up at the same terminal side. This would be pi over 4 minus 2 pi. And I could just actually, so let's say I went here, started here again. So pi over 4 plus 2 pi puts me here, plus 2 pi, plus 2 pi. I could keep doing that forever. I could also go pi over 4 minus 2 pi, pi over 4 minus 2 pi. I could do that forever. All those would be coterminal angles, so there's infinitely many coterminal angles. So some coterminal angles to pi over 4 would be pi over 4 plus 2 pi, which is, again, 2 pi is the same as 8 pi over 4, so that's 9 pi over 4. Pi over 4 plus 4 pi, which is 2 revolutions, that's 16. That's going to be 16 pi over 4 plus pi over 4 is 17 pi over 4. Then I could go 3 revolutions, pi over 4 plus 6 pi, that's 24 pi over 4 plus pi over 4 is 25 pi over 4. And you could just do that forever. You could subtract, again, I mentioned, you could subtract 2 pi. So that's pi over 4, this would be pi over 4 minus 8 pi over 4, which is negative 7 pi over 4. That's, all these are coterminal angles to pi over 4. Then pi over 4 minus 4 pi, well that's minus 16 pi over 4. That's going to be negative 15 pi over 4. That's coterminal. And then pi over 4 minus 6 pi, which is going to be 24 pi over 4, which is going to be negative 23 pi over 4. So all these are coterminal angles. So in general, for pi over 4, the set of coterminal angles would be pi over 4 plus 2 pi times k, where k here I'm representing as an integer. So this would be 2 pi over 4 plus 2 pi times 1, pi over 4 plus, this actually would be 2 pi times 2, this would be 2 pi times 3, this would be pi over 4 minus 2 pi times 1 minus 2 pi times 2 times 2 minus 2 pi times 3, where k again is an integer. And technically here I would make this plus. This would be -1, -2, -3. Again, remember your integers are your positive, negative whole numbers. Alright, so general formula for coterminal angles would be, assuming one revolution is equal to 2 pi or 360 degrees, I'm just using radians here, not degrees. Given an angle theta, there are infinitely many coterminal angles of the form theta plus 2 pi k, where k is an integer. Alright, so here's the sine. I've graphed here the sine function in red. I'm going from basically -4 pi, although it's not on the screen, up to 4 pi. So I have graphed a blue line here, and this is actually going to be equal to sine pi over 4, which is square root of 2 over 2. So this blue line is square root of 2 over 2, or 1 over square root of 2. Then the sine function intersects this at, that's pi over 4. Then you can see it right here. It's hard to read. That's pi over 4. Then add another 2 pi. When I add another 2 pi, it also intersects. So this is going to be 9 pi over 4. That is a coterminal angle, 2 pi over 4. Notice they are the exact same position on the sine curve. And then if I go pi over 4 minus 2 pi, I end up here, which is -7 pi over 4. Then if I come back another 2 pi, I end up at -15 pi over 4. So these are all coterminal angles, here, 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 and here, 2 pi over 4. Again, we did this earlier, but pi over 4 plus 2 pi would be pi over 4 plus 8 pi over 4, which is 9 pi over 4, which we have right here. Pi over 4 minus 2 pi is pi over 4 minus 8 pi over 4. That should be just minus 8 pi over 4. Which is -7 pi over 4. Then minus 4 pi, that's minus 16 pi over 4, which is going to be -15 pi over 4. And all these things show up on our graph where we graph sine. You're graphing sine x versus sine pi over 4, which is again the blue horizontal line. So before I do this example, let me remind you that on the unit circle, right here, these are all going to be even multiples of pi. 0, 2 pi, 4 pi, and then you could have -2 pi, -4 pi, etc. whenever you hit this point here. Now over here, these are going to be odd multiples of pi. Pi, 3 pi, because this is going to be pi plus 2 pi makes 3 pi, 5 pi, 7 pi, etc. Then you could have -pi, -3 pi, etc. So these are odd multiples over here. These are even multiples over here. So I want to find the smallest positive and smallest negative coterminal angle to -1,937 pi over 3. So what I'm going to do is I'm going to do long division. I'm going to divide 3 into 1,937. So that goes 6 times. Bring down to 3. That goes 4 times. 4 times 3 is 12. Bring down to 7. So 3 goes into 17 5 times with remainder 2. So this is be negative 645 and 2/3 pi. So in other words, this is negative 645 pi plus negative 2/3 pi. So that means on a unit circle, since this is an odd multiple of pi, we're going to start here. Okay, let's mark that where we can see it. So we're going to start here. Let's do a different, let's do black. So that's negative 645 pi, but then I've got it, so that's going to be coming this way. Okay, negative rotation. So then I need to go, so this is negative 645 pi over here, but I need to go another 2 pi over 3 this way. So that puts me over here in the first quadrant, because this is another 2 pi over 3 here. Pi over 3 would be here, 2 pi over 3 would be here. And so my reference angle is pi over 3. So my smallest positive coterminal angle is going to be pi over 3. And then a negative coterminal angle would be rotating this way clockwise. Well, that's going to be negative 2 pi, come back another pi over 3, that's 5 pi, that's going to be negative 5 pi over 3. So it's pi over 3, or you're coming all the way to negative 2 pi, coming back pi over 3 makes negative 5 pi over 3. So this is the smallest positive and the smallest negative coterminal angle for that problem. So example here, determine that 7 pi over 12 and negative 17 pi over 12 are coterminal angles. So I'm going to do this two ways. The first way I'm going to illustrate, and this using 2 unit circles here, and the second way is just a fairly simple algebraic equation. So first of all, 7 pi over 12. So we're dealing with twelfths here. So this would be pi. Well, pi is 12 pi over 12. This would be negative 12 pi over 12 also. So 7 pi over 12 is going to fall, is going to be closer to 12 pi over 12 than 0 pi over 12. So it's going to be in the second quadrant. Okay, then 12 pi over 12 minus 7 pi over 12 is going to be 5 pi over 12. So there's my angle, 7 pi over 12. But the actual reference angle is 5 pi over 12. Not that actually we probably need that for this problem, but I'm going to do that anyway. So now it's negative 17 pi over 12. Coming this way, that's negative 12 pi over 12, because this is a negative rotation. Then this is going to be negative 24 pi over 12. Well, 17 is going to be 5 away from negative 12 pi over 12, and is going to be 7 pi over 12 away from negative 24 pi over 12. So it is going to be in the second quadrant, okay? And negative 12 pi over 12, and this is also going to have a reference angle of 5 pi over 12. So these, in fact, you can see are coterminal angles. This is going to be, again, the total angle here is negative 17 pi over 12. So the answer there would be yes. So, but an easier way to do this would be take either angle, and if they're coterminal, they're going to be some multiple of 2 pi. So I can write 7 pi over 12 plus 2 pi k equals negative 17 pi over 12. If in fact these are coterminal angles, k will have to be a positive or negative integer, a whole positive negative whole number. So let's solve this for k. So I'm going to multiply through by 12. So I get 7 pi plus 24 pi k equals negative 17 pi over 12. That's negative 17 there. But actually, it's not going to be over 12 because I multiplied the 12 out. That's why I multiplied through by 12. So I have, this is going to equal negative 17 pi. Okay, so then if I add, if I subtract 7 pi from both sides, so solving for k, I get 24 pi k, and this should be a pi here, equals negative 24 pi. Well, now I can divide out the 24 pi from both sides, and I get k is negative 1, which is a negative integer, so they are coterminal. That's, I think, the easier way to do it. Okay. So now determine if 7 pi over 18 and negative 47 pi over 18 are coterminal angles. So we'll do it both ways again. So this is going to be 18 pi over 18, because that's pi. 1/2 turn is pi. This is going to be 0 pi over 18. Well, 7 pi over 18 is closer to 0 than it is to 18, so this is going to be in the first quadrant. So that's going to be 7 pi over 18. That's also my reference angle there. Okay, so now let's do negative 47 pi over 18. Okay, well, this is negative rotation. This would be right here, this would be negative 2 pi, which is negative 36 pi over 18. And then coming around another 18 eighteenths, well, 36 and 18 is 54. So this is going to be negative 54 pi over 18. That is going to be 1.5 turns, okay? So we're at 47. Well, 47 is 7 away from 54, and it's 11 away from negative 36, so it's going to be in the third quadrant. Okay, and then this reference angle has to be 54 minus, it's going to be 54 pi minus 47 pi. Well, that's going to be 7 pi over 18. Okay, so our total angle here is the negative rotation. This is going to be negative 36 pi over 18, and then we go to negative 47 pi over 18. Well, clearly, hopefully you can see these are not, these do not have the same terminal sides, so they are not coterminal. Let's use the other method to demonstrate this. So I'll take 7 pi over 18 plus 2 pi times k equals negative 47 pi over 18. If they were coterminal, k would be a positive or negative integer. Well, let's multiply through by 18 to clear the fractions. So that's going to be 7 pi plus 36 pi k equals negative 47 pi. Add 7 pi to both sides. So you get 36 pi k equals, that should be, that's minus there. That's subtracting, that should be minus. That's going to be negative 54 pi. Okay, so if I divide by 36 pi, both sides, I get pi equals negative 54 over 36, which you could reduce, but really you can already see this is not an integer. I divide 6 into both those. This would be negative 9 over 6, but I can divide 3 into both of those. So this would be negative 3 over 2. So they are not coterminal. This should be k equals here. So these are not coterminal. Okay, so this is a practice problem. Stop the video and then work it, and then turn it back on to see if you agree with what I got. So find the smallest negative and positive coterminal angles to the angle 109,759 pi over 23. So stop the video and see if you agree with what I get. Alright, so let's work this out. So I'm going to divide 23 into 109,759. 23 goes into 109. 4 times. It's 92. Subtract, that's 17, bring down to 7. 23 goes to 177. I don't know if it's going to get 8 times. It's not, that's going to be too big there. 6 times, what's 23 times 6? That's 18. That's 138. I think we can get bigger than that. 23 times 7. That's 161. That's going to be our limit there. So that's going to be 161. Subtract. Bring down the 5. So we know that goes in 7 times. So we get 7 there. That's 161. Subtract, that's 4. Bring down the 9. 23 goes to 49 twice. That's going to be 46, 23 times 2, so we get remainder 3. So we have 4,777 and 3/23 pi, which is 4,777 pi plus 3/23 pi. So if you sketched a little unit circle here, that's an odd whole number over here. So this would be 4,777 pi. This would be 4,778 pi going this way. Okay, so we have 3 pi over 23. Well, that's going to be that's going to be 3 pi over 23 past this, so our reference angle here is 3 pi over 23. Okay, so we're in the 3rd quadrant. Okay, so let's draw that a little bigger here. So we're here. Got this. This is 3 pi over 23. This is pi, which is 23 pi over 23. So if we add 3 pi over 23 to 23, that's very hard to read. So if we add 23 pi over 23 plus 3 pi over 23, that makes 26 pi over 23. So that's the smallest positive coterminal angle. So now let's go and let's reverse ourselves. So we're here, we're going to go this way. So this is now clockwise, but that's negative rotation. So this is 23 pi over 23 negative, because we're going this way. Come back another 3 pi over 23 in the positive direction. That makes negative 20 pi over 23. So this is the smallest positive, this is the smallest negative. Okay, so here is a practice problem. Stop the video and do the problem and see if you agree with what I get when you're ready to turn it back on. And I'm going to do the 2 ways when I do it. So determine if 59 pi over 36 and negative 85 pi over 36 are coterminal angles. Okay, stop the video, then turn it back on when you're ready. Okay, so I'm going to start with positive 59 over 36. So this would be 36 pi over 36. That's equal to pi. And this would be 2 pi, which is 72 pi over 36. Well, 59 is closer to 72 than it is to 36, so our angle is going to be in the 4th quadrant. So this is going to be, this reference angle here is going to be 72 pi minus 59 pi, which is 13 pi. So this is going to be 13 pi over 36. Okay. Then my other angle is going to be a negative rotation. So this is negative 36 pi over 36. This is be negative 72 pi over 36. This is going to be 72 and 36 is 108. This is negative 108 pi over 36. That's too far. So I'm at 72 pi. I need to get to 85 negative. So I need to go another 13 because 72 plus 13 is 85. So this is reference angles 13. I'm sorry, the reference angle is 13 pi over 36. Notice the terminal angles are the same, so these angles are coterminal. So they are coterminal. So I think the easier way to do it again is to go, okay, start with your first angle, doesn't matter really which one. I'll start 59 pi over 36 plus 2 pi k equals negative 85 pi over 36. So solve for k, so I'm going to multiply through by 36 to clear the fractions. So that's going to be 59 pi. That's what's going to be left over here because the 36's will cancel out. This is 36 times 2 times pi plus k is 72 pi k. And this is going to be negative 85 pi. Okay. So now I'm going to solve for k, so I'm going to subtract 59 pi from both sides. Bring down to 72 pi k. That equals negative 144 pi. Solving for k, divide by 72 pi. So k is going to be negative 2. Well, that's an integer. It's a negative integer. So that shows that they are coterminal. If you got a fractional part here, it would not be coterminal. So angles are coterminal. Okay, if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you and have a good day.